At this point, we're moving into the second half of the chapter. What we've talked about so far is surveys. Within surveys, we've talked about how to take a survey and the types of bias that exist. We are now moving away from surveys. So what we're going to look at now is what are called observational studies and experiments. Today, we are going to talk about the difference between the two, and then when you come to class next week, we will talk about designing them. This page helps us differentiate between the two, but I think it's confusing and not that helpful. So I'll go to the next page instead. What is at the top in this table is the notes, and then we're going to practice it in this example. And that's it that we're going to do together now. What we care about is what is the difference between an observational study and an experiment, and what does it mean for the type of conclusion we can make. So we've discussed we take a sample so that we can generalize to the whole population. And we want to know what can we generalize and to who. And that is called the scope of inference. Scope of inference refers to the types of conclusions that can be drawn from a study. What we care about is can we show cause and effect, and to who. So there are two questions that you need to ask yourself anytime you are reading a study description. As you can see in this table, the first one is the top. Were individuals randomly assigned to groups? So were the individuals randomly assigned to groups, or did you allow them to choose which group they were in? If they were randomly assigned to a group, what is that called? Okay, let me give you a word bank. Observational study or experiment?
Experiment.
Experiment. If I tell you what you have to do, that's called an experiment. Okay, so if the answer is yes, that's called an experiment. If the answer is no, this is called an observational study. Okay, so here's the deal. If you have an experiment, so if you randomly assign individuals to groups, you can show cause and effect. If it's an observational study, so you allowed people to choose which groups they were in, you cannot show cause and effect. So that's question one. Question two, were the individuals randomly chosen from the population? If no, those are called volunteers. So did you randomly choose individuals from the population or not? If you did, you can generalize to the population. So if you did randomly choose people, your conclusion will apply to the entire population. If you didn't, though, if you used volunteers, you cannot make a conclusion to the population. Okay, so for volunteers, the conclusion only applies to those volunteers or people like them. So that's it. Those are the two questions. Yes?
How would you define people like them?
I wouldn't. It's a nice thing to throw out an answer, though. Realistically, that doesn't mean a whole lot to us. What I want to point out to you, students really mess up these two randoms. Those are different. Randomly assigning treatments is different than random selection. So that first one, this is normally called randomizing treatments. That is different from this other question, which refers to random selection. So again, what this table is telling you, if you randomize treatments, you can show cause and effect. If you have random selection, you can generalize to the population. That's what it comes down to. Randomizing treatments shows cause and effect. Random selection allows us to generalize. So we're going to look at a few cases and what it would allow us to conclude. Questions for me? Okay. So here's the example. Many students insist that they study better when listening to music. A teacher doubts this claim and suspects that listening to music actually hurts academic performance. Here are 4 possible study designs to address this question at your school. In each case, the response variable will be the student's GPA at the end of the semester. Before we read those, this is what we're answering. For each design, suppose that the mean GPA for students who listen to music while studying was significantly lower than the mean GPA for students who didn't listen to music while studying. What can we conclude for each design? When it says what can we conclude, what I'm asking you is, can we conclude cause and effect? Can we generalize to a larger population? That's really what it's asking. 1, get all the students in your AP Stats class to participate in a study. Ask them whether or not they study with music on and divide them into 2 groups based on their answer to the question. So it doesn't matter which order we go in, but first I'm going to ask us, were there treatments assigned? Did we force someone to do something, or did we allow them to choose which group they were in? We allowed them to choose, right? Divide them into groups based on their answer to the question. Okay, so we did not randomize or assign treatments. Which means this is not an experiment. We cannot show cause and effect. We can show correlation only. No cause and effect. So we can show that there's a relationship between the 2 variables, but we can't show that one causes another. So that was question 1. Question 2, did we randomly select our participants? No, it's my class. So no random selection. What that means is our conclusion only applies to these volunteers. Okay, so then in a sentence, I would say we can show a correlation, or if you like the word relationship better, you can use that. We can show a correlation between studying with or without music and student GPA for these students only. Technically, or those like them. Like Danny pointed out, that doesn't really mean a whole lot to us. What does that mean? I don't know who students like them. So we can't show cause and effect, we can't generalize. Second study design. Select a random sample of students from your school to participate in a study. Ask them whether or not they study with music on and divide them into 2 groups based on their answer to the question. Did we randomly assign treatments? No, we allowed them to choose what group they're in. Again, that shows correlation. Did we have random selection?
Yeah.
Yes, that allows us to generalize to our population. In this case, who is the population?
All students.
All students at our school. So for 2, we can show a correlation between, I'm going to get lazy and just put blanks there. For all students at my school. Questions for me? Okay, you do 3 and 4 with the person next to you real quick. Okay, so 3, get all students in your AP Stats class to participate, randomly assign half to one, half to the other. Can anybody tell me what we said for a conclusion? Or what we are permitted to conclude? Priyanka, thank you. Yes, we can show a cause and effect relationship between the music and GPA for students in this class. Thank you. For 4, we should have said we can show a cause and effect relationship for all students at this school. And of course, if we were doing this for real, we would put context in, right? More than what I just said. Okay, questions for me before the very last thing we have to talk about, and then we will take a break. Okay, this is most of what your homework is about. There's one last thing, though, that's on your homework, so I want to make sure that we address it. Ooh. Last thing that is on your homework is, the question is, why do observational studies not show cause and effect? And that is because there are uncontrolled variables. And I'm going to write down exactly what I mean by that. When you do an experiment and you randomly assign people to groups, there's going to be differences in those people, but those differences are kind of evened out when we randomly assign people. In observational studies, though, where there's no random assignment, there's going to be these hidden variables that could affect our results. And those are called confounding variables. So for example, if we think of the listening with and without music part, if I took a class and I allowed some of them to listen to music and some not to listen to music, and I allowed them to choose, at the end of the semester, if their GPAs were different, it could be because of the music. Is there any other reason it could be?
They're tired.
Okay.
Don't feel like doing their homework.
Maybe the people who listen to music are more tired and didn't do their homework. Maybe the same thing for the people who didn't listen to music. So there's another reason. There are potential other reasons that could affect the response. Here's how you would write a sentence for this, and then that's it. I'm going to say study habits are a potential confounding variable. It is possible that students who listen to music have different study habits from those who don't. Differences in GPA then could be due to music or study habits. There's no way for us to tell. Confounding variable is any potential difference between the two groups, but it has to be something reasonable. That is what most of your homework is on.